In this video, we will continue our look at the scientific method through the lens of the development of the modern atomic theory. In this video, we will be looking at the discovery of protons and neutrons. As a reminder, in our previous video, we had described how J.J. Thomson, a British chemist, discovered the existence of electrons by working with cathode ray tubes. He found that they were deflected by the presence of an electromagnetic field. From this, he determined that electrons had a negative charge. So Thomson, through the discovery of electrons existing as these sort of subatomic particles, proposed what he called the plum pudding model. Now, plum pudding is a British dessert in which you have a pudding or a custard that has chunks of plums suspended within the pudding medium. It would be akin to sort of a jello with fruit contained in the middle, or something like oatmeal with raisins in it. Essentially a thick, viscous liquid with solid chunks suspended in the viscous medium. Now, the evidence for this was that all molecules are neutrally charged but have electrons. So he knew this because atoms and molecules do not interact with an electromagnetic field generally. So from this, he could infer that they did not contain a charge. So when the electrons were ejected and they had themselves a charge, there must be something that balanced out the negative charge of the electrons. What he proposed was that there was a viscous medium, the pudding in the plum pudding model, that had a positive charge to balance out the negative charge from the electrons. And if you subject it to a large enough electric field, as was done in a cathode ray, you could get the electrons to fly off, right, leaving behind a positively charged medium with the negative electrons coming out. Now, this predates the discovery of radioactivity. So with the discovery of radioactivity, new experimental methods were developed. So up until the discovery of radioactive particles, the plum pudding model fit all of the experimental data. So up till that point, it was a valid theory, right? The plum pudding theory for matter explained the presence of electrons which could be ejected, explained why atoms themselves do not normally interact with a magnetic field, explained why things react in a whole number ratios, right, because they exist as atoms, building off of Dalton's atomic theory. However, when radioactivity was discovered, new experimental methods opened up. There are three primary radioactive particles: an alpha particle, a beta particle, and a gamma particle. Alpha particles are essentially the core of a helium atom. So they are large, fairly heavy in terms of the three particles, and were able to be produced fairly easily once radioactivity was discovered. In 1909, Ernest Rutherford, who was working as a student under Thomson and subscribed to the idea of a plum pudding model, was trying to come up with some experiments to confirm Thomson's model. So within our scientific method idea, this is, you have a hypothesis, the hypothesis being the plum pudding model. You develop some experiments and you collect observations based on those experiments to assess whether they agree or disagree with your hypothesis. So Rutherford proposed this experiment called the gold foil experiment, in which you have a source of alpha particles. These were newly discovered based on radioactivity. So an alpha particle source emits alpha particles, it strikes a gold foil, and then you have a detector, which was essentially a large screen with phosphorescence, so that when your alpha particle struck it, it shone briefly with some light. Now, the reason why gold foil was used is gold is very malleable and can actually be hammered into an almost single atomic layer sheet. So you can get gold to be very, very, very thin, which enabled them to look at alpha particles interacting with essentially a single cross-sectional area of atoms in this particular experiment. Now, the prediction that Rutherford made based on the plum pudding model is that the alpha particles should fly through the plum pudding, the atoms, and not get deflected, right? The electrons were determined to have a very, very low mass compared to an alpha particle, so they shouldn't be able to deflect the alpha particles. What they actually found was the experiment gave some very unexpected results. A majority of the particles did pass through the foil as expected, so they would pass directly through and collide directly opposite from the source of alpha particles. But some of the alpha particles were deflected, and some, approximately 1 in 20,000, bounced back. So some of the particles would come through and get deflected off at an angle, not passing straight through the gold foil. They come off at an angle from where they should have originated. And then some of them, they were found to fly back in the opposite direction. The conclusion is that matter cannot be uniform as it appears. It must contain large regions of empty space dotted with small regions of condensed matter. So what this did was you now have, instead of having a plum pudding model, you have a nucleus model. So instead of the positive charge being spread throughout a large area, instead it's confined to a very small area. That small area was what caused the alpha particles to deflect. So some of them would come close to the nucleus and would be deflected by the positive charge of what was then determined to be the protons. So essentially what Rutherford found was that most of the positive charge was actually located in a very small region. So as the alpha particles came in, if they got too close, the charges would cause each other to repel. The alpha particles would then come off at an angle. Or, in the case of the 1 in 2000 that came back, the alpha particles actually struck something that was hard in the center of the atom and would bounce back. So this led to the development of the nuclear model, where you have a hard nucleus in the middle of the atom with a large amount of empty space that the electrons exist within. Going through the cyclic part of the scientific method, Rutherford had some experimental data that he analyzed. He found that because the alpha particles bounce back, this disagreed with Thomson's view of the plum pudding model. So he needed to go back up and alter the hypothesis, develop new experiments to either confirm or refute the new hypothesis, analyze those results, and if they agreed, then you can move down into the theory and the laws. So in order for it to be a valid hypothesis, it needs to not only explain the new observation, but all the previous observations. So what Rutherford did was he built on the previous model, so building on Dalton and Thomson's models. So Dalton's model had that the atoms were non-subdividable hard spheres. Thomson added to this the concept of an electron. So Rutherford's model needed to include all the aspects of Thomson as well as Dalton. So you still have the atoms existing as spheres, indivisible through chemical means. Within them is contained electrons. Now, the theory itself that Rutherford proposed, this nuclear theory of the atom, contains 3 basic parts. Most of the atom's mass and all of its positive charge are contained in the small core called the nucleus. This is consistent with Thomson's view that the electrons have a very low mass to them and are able to be pushed away. It also agrees with the observation that only a few of the alpha particles collided and were bounced back. So it needs to have a small core to agree with the idea, or to agree with the observation, that some of the alpha particles bounced back. Most of the volume of the atom is empty space, through which the tiny negatively charged electrons are somehow dispersed. This also is consistent with the previous ideas of Dalton, who said that the atoms are these come in whole integral packets that react with each other to form molecules. It also agrees with some of the key parts of Thomson's model, which contain the electrons. And then, in addition to this, is the idea of empty space, which agrees with the experimental observation that the vast majority of the alpha particles were able to fly through the nucleus without being deflected. The third part is that there are as many negatively charged electrons outside the nucleus as there are positively charged particles, which they called protons, within the nucleus. This enabled the atom to become electrically neutral. So one of the observations was that regular material, atoms and molecules, don't interact with an electromagnetic field. They don't get pushed one way or the other, and so they have to have a neutral charge. Because the alpha particles, which themselves are essentially the cores of a helium atom, they do have a slight positive charge. They interacted with the positive charge of the nucleus, so because they were deflected, not the ones that bounced back, but the ones that were slightly deflected, this is the two positive charges from the alpha particles interacting with the nucleus, causing it to deflect up. This third point agrees with that particular observation. Rutherford's model itself was highly successful. It explained a lot of the experimental observations, but it failed to explain how the masses of the various elements worked. For example, a helium atom does not weigh twice as much as a hydrogen atom does. So to account for the difference in mass, one of Rutherford's students, James Chadwick, demonstrated that some of that unaccounted for mass was due to neutrons, which are neutral particles within the nucleus. The mass of a neutron is similar to the mass of a proton, though it has no electrical charge. So the protons still explain the entire positive charge that is found in the nucleus. The neutrons are there to explain for the missing mass.